it's recording. Yeah, we did 2 molarity, right. Those are 2 molarity problems and we found the moles of each. We know this one's limiting because it has less moles, and I need 2 of them for every one of those, so I can't possibly have 2, I don't have 2 times as much of the KOH as I do of the NiSO4, right? So that one's a limiting reagent. All right, grams of precipitate. Once we know which one's limiting, then that's where we do our stoichiometry from, right? All right, so D is going to be, start with the 0.194 moles of KOH. And now you got to use the balanced equation. So for every 2 moles of KOH that reacts, we make 1 mole of the precipitate, which is the nickel hydroxide. So 1 mole of the nickel hydroxide. And then they want grams, so we need the molar mass of that. Did anybody add it up? Of the nickel hydroxide? 93?
Wait, why did you start?
I got the answer right, so.
Okay. What?
Did you start with 0.0194 because of the OH, like KOH?
No, I started with this because it was the limiting reagent. So when it runs out, that's all I can make. So I have to do the stoichiometry based on the limiting reagent, right? So, uh-oh, somebody grabbed the door. You needed to wake up anyway, right?
Yeah.
Did I forget? Sorry, I'll stick it in a minute. All right, somebody remind me so I don't have to stop in the middle of this and do attendance. All right, so that will give us grams of nickel hydroxide. So somebody do the math for us.
So that's the answer for the grams?
That's the answer for the grams, yeah.
Is there a way you can like unlock the thing so I can go back and look at this?
I think you can go back and rework them anyway, can't
You
you?
can do it
Well,
for
it
practice.
counts like for the grade.
No, it's not going to count for the grade, but you can rework them.
What do you think? Is this regular Kim or something?
Yeah.
What'd you get?
What'd you get?
I got 0.9021.
Somebody verify?
Let me. So close. 0.9021.
Okay, so that's 2 of you. That's probably right then.
I got that too.
Okay, good. 3. All right, so we're good there. Nothing is different. This has just been a regular problem so far. When you get to E, E is the one that's trouble, okay? Actually, F and G are easier than E. So maybe we need to start with F and G. I don't know. This will be easier to see if you look at the net ionic. What's going to end up going away in the net ionic?
Potassium.
What's going to be your spectator ions? Potassium and
Sulfate.
sulfate end up being your spectator ions. And your net ionic is really 2OH minus plus Ni2 plus yields NiOH2. So these 2 never change concentration, right? Whatever is there before is what's there at the end of the reaction, right? They're the amount, the number of sulfate molecules, right? The number of sulfate ions, really, that are in solution is the same before and the same after because it doesn't participate in the reaction. The problem is its concentration is not just this 0.24 molar. Why?
Because that's both.
It stays.
They all stay there, so why can't I just say that the concentration of the SO4 stayed 0.24?
That's not nickel and
It's because you added 2 solutions together. So what happened is you basically diluted those sulfate ions because you now have a new concentration. That's the problem. All right, so let's just do the sulfate ions first. If we started out with 0.24 of the nickel sulfate, we had, and it probably would be easier. Can I flip the page? But I need this picture. I need this on the other page. Wasn't it 3.3 for the do now?
Yeah,
3.3. You didn't get it? All right, let me. You changed moles. You use the mole ratio from the balanced equation. That might be why. Okay. All right. So think about this. K plus is reacting with OH minus. I'll write the whole thing out. You'll see it.
Is this the
Yes, but I'm writing the whole thing at the moment.
So everything breaks apart besides the NaF.
Besides this, yeah. And this had a 2 and a 2, right? And this had a 2 because this was K2SO4. Okay, so now that balances, right? All right. That's what the complete ionic looks like. The sulfate that was there before is still sitting there afterwards. The only thing is when you poured these things in a beaker, at first, you poured in 114 milliliters of 0.17 molar KOH. Then what'd you do?
You added
200.
Yeah, you poured some more. You poured 260 milliliters more of 0.24 molar NiSO4. So now what is your total volume? So your sulfate ions, the moles that were there before are still the moles that are there afterwards. So it ends up being V1M1 equals V2M2. Do you want me to do it that way, or would you rather me do it stoichiometry so it makes more sense? All right, then the number of moles, so 0.260 liters times 0.240 moles of nickel sulfate over 1 liter. And then for every 1 mole of nickel sulfate, I get 1 mole of sulfate ions. Do we agree? This will be how many moles of sulfate were originally added. Okay, so somebody give me the number.
How did you get why is it 0.24 mole in that?
Molarity is moles over liter, so I just wrote it as moles over liter.
Oh,
Instead of capital M, I wrote it as moles over liters. Okay, so 0.26 times 0.24 is what? 0.0624 moles of sulfate was originally added. But what's the new concentration? What's the new volume that the SO4 is in now? 374. So 0.374 liters. Now divide that, and that will give you your new concentration.
Couldn't you have just said, since it canceled, you could have just taken when we did it like the first time from like part C, 0.624?
Oh, probably. I just didn't pay attention that was.
And then
Yeah,
do
you
the
could have
same thing.
started here. I just did it again.
Wait, mole sulfate originally added?
Yes,
So is that the same thing as how much is reacted?
none of it reacted,
Okay.
right? The sulfate that was there at the beginning is still sitting there as a spectator ion at the end. So the number of moles of sulfate that you put in the container to begin with is still the number of moles of sulfate that's sitting in that container in that solution running around at the end. Nothing happened to them. They're still running around. They just now are running around in the whole solution, not just the little piece that you did, right? Okay, so what's the molarity of the SO4? Okay, so then that's the concentration of the SO4. Now you do the K plus.
What is the answer?
Oh, sorry. I moved it. Do what? That one? Right there, 0.0194 moles of KOH. Is that what you wanted to use, that number?
I'm still a little confused by. So you take like the the original solution and you do a stoichiometry problem with it.
This is, well, I mean, is it stoichiometry? I'm just really doing how many sulfate ions are in there. I mean, yeah, I guess. You really could do the same problem with V1M1 equals V2 M2. Because you know the concentration of the SO4 and you know you put 260 milliliters with point,
Do the same thing.
yeah, you'll get the same thing. And then you can do, you don't know the new concentration, but you know the new volume is 0.374. So you can solve, and you should get exactly the same thing. Okay, either way is fine. Either way is fine. You just have to think to do that. Because what this says is that moles at the beginning equal moles at the end. And that's what we did, right? The moles of the sulfate didn't change. The molarity changed, but the moles did not.
It changed because there was more solution.
Right, because there's more solution, exactly. So the concentration changed, but the moles did not change. Uh-huh.
For NI,
Okay.
would you do this same thing?
Well, you will, but Ni gets used up, right? Because where is some of the Ni sitting? At the bottom in the solid. So the Ni becomes a how much excess is left over problem as well as this. That's why I saved the Ni. So let's do the K first and then we'll do the Ni.
I have like 6 different tries on that,
Wait,
Oh, that would charge me. That's a lot.
I tried doing it both ways, but I got two different answers.
Oh, we shouldn't get two different answers.
But yeah.
0.0194 moles. So we have 0.0194 moles of K plus, right?
Well, you made it-
Over point.
376, right?
374.
374. What does that come out and give us?
I got 0.052.
That's what I got. But then I tried to do the stoichiometry way.
Okay. Well, that is the stoichiometry.
Or
Right?
like the other, like the starting with the.
Okay, so you should have 0.114 liters times 0.170 equals 0.374 times. Yeah,
Oh wait.
that doesn't give you the same thing.
No, I did it this way down here when we did, like on SO4. How we said like. You did the long way. Yeah, the long way.
Okay, so you started with 0.114 liters times 0.170 moles per liter. And then for every 1 mole of KOH, you have 1 mole of K plus.
Oh, you only had. You
And
don't use
you-
two.
There's no 2 there. It's not K2OH.
Oh, I was thinking two because of the two. That's like. Balance the 2 in
No,
front.
no, this is within that formula.
Okay.
And
That's what
so
I was
yeah, you should
do
get,
stoichiometry within the same thing.
right, right. That's why I hesitate when she said, oh, it's stoichiometry. Is it really?
It's not changing substance.
It's not changing substances through a chemical reaction.
It's just-
Exactly. It's using the
It's a
subscripts in
ratio.
the, right. It's using the ratio in the formula of the substance itself. Right. Okay?
And you take that and divide it.
Right. So do we get the same number everywhere? No matter which of the 3 ways you have it done?
We should. We're doing the same thing.
We are doing the same thing. We should get the same number
Just
everywhere.
the second way, you don't have all like the extra stuff attached, like subscript, not subscript, but like. chemical
Yeah, the
reactions.
only thing you have to be careful with the V1M1 stuff is just make sure everything's 1-to-1.
Yeah.
That's the only thing. Just make sure. That's the only trick to that one. All right. So those are easy enough. Now the nickel part, it's not impossible. What happens with the nickel part is it's the excess reagent, right? The nickel sulfate was the excess reagent. So some of the nickel, because our net ionic, was this, right? all of the hydroxide gets used up and is in there because it was in the limiting reagent. Agree? Like if I go back to the original equation, where do we write it? This was the limiting reagent. This was the excess reagent. So all of the hydroxide got used up and went into the solid. So if they asked you the concentration of the hydroxide, what would it be? 0, because all of it's in the solid at the bottom, because that was the limiting reagent. But the nickel, on the other hand, was not. It was the excess reagent. So all that can is in the solid with the hydroxide. But there's some left over floating around in the solution that didn't get used up, right? All right, so we have to figure out how much nickel is in the solid and how much nickel is still in the solution.
And then subtract the two.
Well, not subtract the two, but yes, there's a subtraction to get how much is left in the solution. So how can we find out how much nickel is in the solid?
We can just do the same thing we just did.
Doing stoichiometry to the precipitate, right? From the limiting reagent, go from the limiting reagent to the excess reagent. Well, you don't have to go to the precipitate, but to the excess reagent to find out how much nickel was used or went into the precipitate or is in. That's however much got used up with the hydroxide is what's in the precipitate.
So whatever got formed.
Yes. So do you want me to do it back from scratch? So the limiting reagent is the hydroxide, the potassium hydroxide. Whoops, except I didn't write moles. Moles of KOH. Then in our balanced equation, for every 2 moles of KOH, we used 1 mole of nickel sulfate. Agree? And then every nickel sulfate will provide 1 nickel ion. So this will tell me how many moles of nickel ions are basically in the precipitate, right? Okay, so do the math for us.
Why can't you go directly from the nickel sulfate to the nickel ion?
Here,
Like you don't.
you could have if you looked at this.
Because you said like go from the limiting to the excess, but what if you just started with the excess and then went to the ion?
Then you just know how many ions you have. You don't know what was used and what's in the precipitate. It's just how much was there originally.
About
0.0 what?
0.01.
Even?
101,224.
I got 0.0096. So
Yeah, so you're wrong.
Okay, we'll call it 0.1 then. All right.
Wait, then how are we getting 2 different answers when we're typing the same exact thing?
we'll just.
All right, well, somebody else punch it in.
Type in 0.1.
0.00969. Yeah, that's what I
969. So really 0.0097. Yes?
got. Oh, okay.
Okay.
You do 144, 114.
Just like, oh, it's out of the button. All right. So this is how many moles of nickel went into the precipitate. It's how much got used up in the reaction. It's how much was used. So how many moles were left over? We'll go back to your nickel moles. Where was our nickel? This one, right? That's how many moles of nickel were there to begin with. So 0.0624. Whoop.
Is it moles of nickel or moles of nickel sulfate?
It'll be the same
Why?
because nickel, this is nickel sulfate for every mole of, because it's 1 to 1. Of nickel, okay, I'm just writing a lot. was what we had originally minus the 0.0097 moles that we used, or that's in the precipitate, right? So we get what? 27 moles of nickel 2 plus left over. Okay, once we're in moles left over, they didn't ask us for moles though. What did they ask us for? No, they didn't ask us for grams. Molarity. They asked us for concentration. So now what do I have to do?
Put that over the new volume.
Over the new volume. What was the new volume?
377.37.
Yeah, this is the hard one. This is the hard one.
I'm guessing this won't be multiple choice.
It will not be multiple choice. What?
Like 2 of these on the test.
That's all you probably have time for. Yeah. What was the answer? 141.
There's like no quick way to do
There is no quick way to do this.
Yay. So how many?
Nope.
I'm gonna start with these.
I don't know how it made it. There was about 30 last time on the last one, on the old
I'm
one.
gonna start with the short answer.
See, I would do that, but then
Then I
it
would-
gives me anxiety that like I'm gonna be stuck on those for 30 minutes and I'm not gonna have time to just get the easy ones knocked out. So then I'd be mad at myself because I didn't get the easy ones.
Probably the best thing is to time yourself and leave. This test may not have free response like you had last time with the ABCDE. It may just have short answer questions, just because of this particular test. But on normal tests where you have the ABCDE free response at the end, they should take you 20 minutes apiece, no more. So if there's 2 of those, that's 40 minutes. So you could take, and basically halfway through the class, you should have been on the free response. That's kind of how you need to start timing yourself on the test. This particular test, though, won't quite look like that. I'll try to think about the timing, and I'll tell you. Remind me and just ask me where should I be at what time, and I'll try to help you.
I know,
Huh?
that's what way
It's like
shorter.
this block is only, if the block is, this block is the same as
Every other block.
but it just feels
So short. I
But
know.
The second block feels like the longest block I've ever been in because Spanish grade I just don't like it.
Oh,
But it's the same. I mean, it's like the
this
same
one's
time,
just
I think.
lots of content, lots of stuff, really fast. That's the hard
Like
part
my
of this
third block
class.
feels like 3 hours long.
Yeah.
And
all
then
we
this
did
one, we
was
don't
say
have
that.
enough time to finish anything.
My
Third
third
and seventh block
block
feel like forever. Like I finished.
It's coming up. Oh no, it's not today. It's tomorrow. All right. So does that help? Is the can't talk? Does that help a little bit?
I'm confused how you got the 0.0527.
Where is it? Oh, here. Subtracted. Yeah, that's. Oops, I didn't mean to mark there. It's this. It's
Is
this
it what you started
subtraction.
with? Is what you
Yeah, it's
had
what you
ended?
started with, but you have to put it in moles. It's what you started with minus
you
what
used.
went into the precipitate. And that's what gave you how much is left over
And then you have to do that in the liters
to find the molarity. Correct. Correct. I can promise you there will be at least 1 or 2 of these on the test.
Yay!
Because that conceptual thinking of where the ions are and if it's left over, if it's there, that's AP level. That is conceptual. Do I really understand what's going on in the reaction?
Is it gonna have all those other parts to it?
Yeah, I don't know. You have to do all those other parts to get to it. I mean, you don't have a choice. You have to identify the limiting. You have to figure out what's precipitating. You have to. You have to do all of those parts to do that one question. So, yeah, will they all count as separate questions? I don't know.
Or
So
a
it'll be like
question
short
like
answers.
a question like number 2 that says like classify the following conditions based on whether they're before the equivalent point
Oh,
or
yeah.
the equivalent
I
point.
think we know.
Oh, that's a good one to look at.
Is that gonna be?
That was question 2. Well, anything you've had is fair game for the test.
Because I don't remember.
That video.
I
We didn't look at it in that way. Did you not watch the video?
I did.
I'll
You had
watch
to
it.
watch it to do the
You
test.
have to
I had
watch
to put
it.
places.
And
I did.
I was watching it and it was going so slowly and I was over here like, are you doing anything? Like, is this
Right, because it doesn't go up very fast. Yeah. All right. So in this one, you're talking about this last one at the end, right?
Yeah.
All right, it says a volume of 100 milliliters of 1 molar HCl is titrated with 1 molar NaOH. Classify the conditions whether they're below, above, or at the equivalence point. You should be able to look at this and tell me where the equivalence point is going to be. What does the equivalence point mean? What's actually happened right at the
When-
equivalence point?
When it
Whatever
changes
you
color.
have and whatever
Okay,
you're
changes.
putting in is like
Exactly reacted.
Yeah.
Right. When the moles of what you know and the moles you're reacting it with have exactly reacted each other, you're at the equivalence point.
So is it really like you have equal amounts of everything?
Well, this one you happen to because they're both 1 molar, right? So if I have 100 milliliters of HCl, then it's going to take 100 milliliters of NaOH to get to the equivalence point. What if this was 2 molar instead?
You would need 200.
Let me see if this will let me write on. Will it? Yeah. Yeah. What if this was 2 molar?
You only need 50 milliliters
Right.
Why
you-
only 50?
because with the 50 milliliters is 0.5 liters, isn't it? Yeah,
0.05.
0.05. So it would.
Well, you doubled the concentration. So you're only need half the volume to get the same number of moles of OH minus out of it. Right?
So if it was 300, you'd only need 25.
No, it'd have to be 4 to need 25. But because it would be a fourth. If it was 3, it would be 33. Think proportions. They're 1 to 1, right? Because HCl plus NaOH is 1 to 1, right? So we can use the volume of the acid times the molarity of the acid equals the volume of the base times the molarity of the base, because it's 1 to 1. So if I know that there's 100 milliliters of 1 molar, and this one is 3 molar, right? Let's say I changed it to 3 molar. What would the milliliters be at the equivalence point? 100 divided by 3, which ends up being 33 milliliters, right?
Okay.
So the equivalence point is going to happen when I use 33 milliliters of NaOH.
You were just doing that little BM
Mm-hmm.
in your head.
Yes.
Okay. I didn't know where you just spit these numbers out from.
Yeah. Well, or it's ratios too. I mean, you could do ratios, but proportions like you do in math, same thing. But so once you realize that the equivalence point you had to use in the original problem was at 100 milliliters of NaOH, then this one, that one, all were before the equivalence point, right? Because they haven't quite put in, this is 50, this is 10, this is 5. They haven't put in 100 milliliters yet. The 100 milliliters is at the equivalence point, right? And then anything above that is after the equivalence point.
Oh.
I thought you said 33 was the
Well, I made up, that was me making up if I changed this. Like if I changed the original problem. So if I'm looking at this original problem, 100 milliliters is the equivalence point. Because this was a 1 right there.
Yeah, because it's like literally what it just said. So.
Mhm. Does that help with that? Okay. All right. What else from the homework?
This isn't a question about how to do it, but on number 4, when you had to find the grams per mole on the test, if we have a question like that and we don't put grams per mole as the unit,
Well, I count it wrong. I'll count it half wrong if you don't have units on there. Yeah.
I missed that too at first.
This one?
Yeah, because it's like
moles. Oh, because that's for moles. But it actually it makes you put grams
Per mole. Because the molar mass is in units of grams per mole. That's why you can write the grams over 1 mole in your conversions, right? It's grams per mole. It just is. Okay?
and we'll have a periodic table.
You'll have a periodic table. You'll have clues in your questions to where all you have to have is those 4 rules for the solubility memorized. You do have to have your gas rules memorized, right? That H2CO3, H2SO3, and NH4OH all break down into their gases in water, right?
So that you only need to just know what they are. Like, you don't need to know anything else. Or like the gases.
Correct. You just need to know that I don't write H2CO3 as a product. I write H2O and CO2. You need to know that.
But if it wasn't, if it didn't break up, then you would write what the first thing you just said. Like if it was a different one, it would be like H2, whatever it is, and not water.
Oh, right. Then it stays whatever. Right. Only those three, right, break down into the gases. You need to have those memorized. You do not have to have the activity series memorized. That will be either it will be given in words or you'll have a little activity series out to the side. So that there's no need to memorize the activity series. For single displacement,
Oh.
right? Because some react and some do not. So if you, or it'll say that the reaction reacts, and so you know it does. You don't have to check the activity
Even
series.
if it doesn't technically react. Will it
Well,
say-
if I want you to check, I'll give you the activity series. If I want you just to write it, then I'll tell you it reacts.
Are we gonna do if it asks us to balance an equation? Are you gonna want to solve it as an ionic?
It'll tell you whether I want the net ionic or just the balanced molecular equation. Most of them are net ionics.
Okay, what is it when
Um,
they all cross out?
No reaction.
No reaction.
So then what is no net ion?
I wouldn't write no net ionic because the molecular is the net ionic.
So really, it's
Everything has a net ionic. It's just sometimes you don't cross spectator ions out because there's no ions. I
it
mean,
would
they
just
all
be their
stay.
balanced equation.
It's
and
just
then,
the regular balanced equation.
So
Right.
what if it was given and like the balanced equation was an option and no reaction? That wouldn't be. Like, would you rather write no reaction or just the balanced equation?
For like a double displacement that doesn't really react.
Or like when nothing crosses out and for the net ionic?
Oh, just write the balanced equation.
Okay.
Yeah. I thought you were saying when everything crossed
Do you
out.
want us to like specify that hey, no reaction for the net ionic, or like just
No, because otherwise what you're telling me is there's no reaction, and really that's not what you mean. Because think about, I'm trying to think of one that you did.
because something did happen, it's just nothing was able to be more soluble or something.
Right. Well, like when you had, I think it was the KClO solid one was heated. It makes KCl plus O2. Lots of you want to tell me this one's aqueous, but it's really a solid. Why does that one have to be a solid?
You
Because
just
it's a
took
gas.
This is a S. You can't read my,
No,
you can't read my scribble.
O2.
There's no water anywhere.
Yeah.
Like,
There's
you
no
don't break up if
water.
There's water.
Yeah, if there's no water, there's no way for it to be aqueous and split into
So
its
if we
ions.
had,
There
like-
has to be water somewhere. So this one, nothing splits up. So you can't turn around and tell me no reaction. There was a reaction. You just don't do anything else. This happens to be, it's just like an empirical formula is the same as its molecular formula. The molecular equation is the net ionic. They're the same. There is no, it's just the same thing. So I wouldn't write anything. I would just write the molecular equation and be done.
What else have we done other than like oxidation, titration, and reactions? Is there
That's it.
anything else?
Can we
That's
go
it.
over like
You do have to be able to do oxidation numbers.
that?
You've got to be
Yeah,
able
I
to
can
assign
do that.
oxidation numbers. You've got to be able to write balanced equations in net ionics. You got to be able to do molarity, and you got to be able to do the stoichiometry with the molarity, the titration stuff.
I like that type.
What about
okay,
just
I
the
don't know why.
wall?
I have a question.
I'm good first.
Whenever, okay, you know how like there's certain transition ones that have like set charges? When they're given like other ones, how do you figure out what their charge is and they don't give you the parentheses?
They'll tell you. I'll tell you because the AP test would, and so will I.
So you don't just assume. With
You
whatever
can't
the
just guess that
polyatomic
it's plus
ion
2.
is.
Well, if you have a formula, you can tell.
Like say you had. Like,
I mean, like if it's FeSO4, you know it's plus 2. But if they're just writing iron, surely they won't just write iron sulfate. They'll tell you.
Okay.
And if it shows up, I guess your other question is like when it's single displacement, I guess. When it's, I don't have the activity series memorized, but if it's iron plus copper 2 nitrate, when you go to the other side, now you're guessing.
Mm-hmm.
Right. I'll tell you.
You would tell us in that situation?
I remember,
Yeah.
because I remember like when we were doing it on Master Kim, it expected
Right. It
Yeah,
expected you to
wouldn't
know.
know.
And that's because they were using the activity series in the book and they only gave you one option.
Yeah, because
That's why.
Because it didn't really matter for the reactant side, because it was like oh, all by itself.
Right.
It's like,
Right. So I will give you a clue somehow.
Okay, so you know, NO3 is always aqueous, right? But there's no water. so
Well,
it's
but
still-
this would have been, yeah, it would have. This solid would have been put in a solution of copper nitrate. So yes, there is water. So this would stay aqueous, and this. So your net ionic for this would be. Whoop! I forgot an arrow. That's the net ionic.
Okay, I can do that.
Can we go over oxidation?
Yes. All right. Let's do. Can we go over what? Oh, neutralization too. That was the other thing on y'all's list. All right. So chromate ion. Tell me the oxidation number of chromate. Don't yell it out. Everybody get a number first.
Wait.
I need to come to these notes.
Yes. 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 And what else do you need? Did I give you enough? Did I give you enough review? Didn't I print out? You got to remind me because I don't remember what it. Yeah, and I printed you out a thing. And then do you want some more combustion analysis? Here, let me just give y'all several things to find the oxidation number of. Oh. Okay. All right. Let me find you some more stoichiometry. Y'all do the oxidation numbers of everything in that. Do the oxidation numbers of and we need another one.
Of just the sulfate or of
Nope, I want you to do every element. Do the oxidation numbers of every element. You know what I can do? Might take me longer though.
How do you write it? Like after,
The oxidation number?
Like, do you like put it up top? Or?
I do, but you can. It just needs to be the positive or negative and then the number. Here's what I'll do. I'll do you another assignment in Mastering Chem, like an optional one for you. That way when you do them, you can check your answers. Or would you rather have paper? What would you rather have? Would you rather have paper or would you rather have, okay, then never mind. Don't let me do it this way then.
They all have to have options. Oh wait, never mind. Ignore me.
Oh, I just clicked on the wrong thing.
So for the first one, does it have to equal 0 or does it have to equal -2?
Has to equal -2.
So
They have to add up to the overall charge.
So if they don't tell you, what do they equal up to?
Just 0.
Well, they
They tell
tell
you
you because the compound's neutral, so it is 0.
Like there's not like a two.
They're so mean to each other.
There's not a 2 negatives. See, like,
Hey,
there's a two negatives. So
there
it
has to be
equal
a
2.
lighthearted attitude in this class. There's only 8 of us.
So the
That's
other
true.
3 are equal to 0. It doesn't
Oh,
have
this
a
is taking
negative.
forever.
I need to make a note of that.
Wow, the internet is so slow.
It's always
It's the worst.
It's been worse
every
this
classroom
week.
needs to have their own Wi-Fi.
They found there was some virus going around through their stuff yesterday, and it was going through all the Windows computers, which y'all don't deal with, but
Okay, I think I just made this.
So like
This
chromate,
was called.
they'll all equal -2.
the chromate ion total will be -2, yes. Oh, I hate that. use it, but I hate this online textbook.
So like, say you have like the NA2 when you write it, do you say NA2 and then the charge, or just NA and the charge?
NA in the charge.
Do we need to know like every single oxidation rule?
Yes. You need to know your oxidation number. How to assign oxidation numbers? Yes. Yes.
You have to write them out.
Okay, I want to print this page. Will it let me print?
I don't foresee myself being much
I need to print. Will it not let me? Oh, seriously?
Excuse me. What does this say?
All right, this is gonna look bad, but what is it doing?
What? Six. I mean, there's no reason to. Go for it. Four is for the